Hello everyone. So today, previously we had successfully designed a payment gateway integration, right? So today we are asked to design a form validator, right? Form validator utility, right? So let's see what the question states here. Design a form validator utility in Python that allows adding multiple input fields, right? That allows adding multiple input fields. This is very important. That allows adding multiple input fields, each with customizable validation rules, each with customizable validation rules like required minimum max length, right? Minimum maximum length, email format as well, and this one age check as well, right? So the utility should validate all the fields and return the description error message, right? Descriptive, sorry. Return the descriptive error messages for invalid inputs. So this is the question actually. So this is simple. Let's go with the functional as well as the non-functional requirements. Let's collect the functional as well as non-functional requirements. Yep. So let's go with the functional requirements. The first one, it should allow dynamic form creation with fields like name, this one email, age, password, etc. Age, password, etc. We should allow dynamic form creation with fields like name, email, age, password, etc. Each field should have validation rules. Each field should have validation rules. So this is one of the requirement as well. The third one should validate inputs and return the descriptive validation errors. This is important, right? Should validate inputs and return descriptive validation errors. So this is the main requirement. Let's move on with the non-functional requirements here. Or we have two more actually. It should support custom validators. Yeah, this is very important. Yeah, it should support custom validators as well. It should provide a clean summary of results after validation. It should provide clean summary of results after validation. Yep, this is important. Now let's move on with the non-functional requirements. First thing here is code must be extensible for code must be extensible for adding new file types or new field types or rules, right? Code must be extensible for adding new field types or rules actually, right? It must be modular and extensible. It should be open for adding new validators in simple terms, right? It should be lightweight, dependency free, and run entirely in memory. Run entirely in memory. We don't have to make use of any external database as we are just going with a single file CLI demo, right? So third one here, it should handle concurrency safely for the simultaneous validations. Yep, it should handle concurrent validations safely. Yep, the final one, it must have simple developer friendly API for the quick integration. Yeah, it must have simple developer friendly API for quick integration. So these are some of the non functional requirements. Yeah, now as we have complete idea on the functional as well as the non-functional requirements, let's do one thing. Let's quickly discuss the this part, what do we call algorithm choice. So based on the requirements and the question, right? Requirements and elaboration basically, and the question that we had discussed, I went with this particular algorithm basically, right? So rule-based validation using strategy pattern. For the previous question also, we went with the strategy pattern itself. So for this also, we'll be going with the same thing, nothing but rule-based validation using strategy pattern, right? So this is fine. Rule-based validation using strategy pattern, right? So here each validation rule is separate. This one separate callable, right? Each validation rule is a separate callable, nothing but it is called as strategy, right? Each validation rule is a separate callable called strategy, right? So if you know the strategy design pattern, you'll be it will be easier to write the code actually. If you don't know this one strategy design pattern, it's better to go to the playlist, design patterns playlist. So it's in the Python as well. We have discussed, and we have discussed the same within this one by considering the JavaScript as well. So if you're doing in the JavaScript, so this remains same. Approach and other stuff remains same. Only thing is code might change, right? The syntax is must might change. That's it. Yep. So you can watch any video there. If you're doing in JavaScript, you can just watch that. If you're doing in if you're following along with me currently in the Python programming language, so you can just go through that video and you can just come, right? So you'll understand the things clearly, right? So if you know strategy patterns. There are different patterns actually. 10 important patterns we have discussed actually. You can just watch the video and you can come, right? So each validation rule is separate callable strategy, right? Validation engine, what it does, it iterates fields and executes rule functions dynamically. And one more thing, this allows because of n validation, where n is nothing but the total fields into average rules per field actually. So the time complexity for the code that we'll be writing would be big of n actually based on the algorithm that we have chosen, right? So yep, the last thing is it is easy to extend by adding new rule strategies. Yep, so based on the algorithm that we have chosen, right? So we'll be going with a rule-based validation using strategy pattern. Next, let's move on with the concurrency and the data model, right? So here, first thing, let's discuss about the data model. So each form is collection of field objects. We know that. Yep, there will be different field objects, right? Each form is a collection of quite obviously field objects. Each field has name, value, and a list of validators. Name, value, and a list of validators. So this comes under the data model. Let's move on with the concurrency part. Each validation is stateless. Yeah, each validation is stateless. Parallel execution is possible. Parallel execution is possible, right? So then it is thread safe. It is thread safe. Why it is thread safe? Since each form instance has its own independent state, right? So we that's the reason we'll be going with the strategy design pattern, right? So mainly. Now, as we have discussed the main parts here, one is this one, what do we call concurrency in the data model, and the another one is algorithm choice discussion. Let's do one thing. Let's move on with the UML diagram, main part. Yeah. So here we will be going with the three classes. One is form validator, nothing but main class or the base class actually. Yep, main class or the base class, and we will be going with a field, this one as well, field class as well, and the validator function class. Yep. So main form validator class. So field class is directly dependent on the form validator, and validator function is directly dependent on the field class, right? So form validator consists of the this one parameter fields, right? Which is of the type list, and it consists of the two methods as well. One is add field, and another one is validate. Two methods, add field and validate, right? So this is fine, I believe. Field class consists of the three parameters, name, value, as well as the validators. Name, which is of the type string, value, which is of type any, and validators, which is of the type list, right? So then we will be going with the value method as well within the field class, right? So we need to validate, right? So for that purpose, we need to validate that particular field, right? So whether, we need to validate that particular field. So this is fine. So we'll be going with a validate method within the field class. Then the validator function, where we will be going with a call method. Yep, where we will be going with a call method, and it is directly related to the field class validator function. It is directly related to the field class. So just pause the video, have a look into it. Look into the this one UML diagram. So based on the requirements and the question, and also whatever we have discussed, whether it may be algorithm choice and concurrency in the data model, we have designed, or I have designed the UML diagram here, right? The exact same thing will be articulating in the form of code. We'll be adding the logic and we'll be writing in the form of code. That's it. The same parameters will be making use of, the same methods will be making use of, right? Along with the classes, the same classes, same methods, and the same parameters will be making use of. Only thing is we'll be adding logic. That's it. We have successfully designed a UML diagram. Now we have discussed the algorithm choice as well as concurrency in the data model. Most of the things we have discussed, right? So let's do one thing. It's good time to write the code. Let's start writing the code. So first thing I would like to tell you is the functional goal, or the functional requirement that we saw. We have to build a simple extensive, this one extensible form validator utility, right? Each field can have multiple validation tools. Required minimum length, maximum length, email format, and numeric, nothing but age validation as per the question. And also validators return either true if valid or an error message. This we know. The main form validator collects all the field errors neatly, right? So let's start writing the code. First thing, we'll be importing RE, nothing but it is used for the email validation pattern matching, right? So I'll just go with here, sorry, import RE, right? So the next one is we have to define the field class, right? So I'll just go with here class field, right? Class field. We have to go with the class field. The first one, let me go with the initialization part actually. I'll just go with init. So along with the self, I need certain things. One is name, another one is value, and the next one is validators, right? So validators set to none. Yep, validator set to none. Yep. So first thing here, let's go with a field name like email, username, etc. So I'll just go with here name and let me initialize this one to the name. This is fine. The second one, let's go with the actual user input value, right? So I'll just go with the value here. Let me initialize this one to the value. And the third one is, let's go with a list of validator functions that is assigned to this particular field. So I'll just go with validators here. I'll just initialize this one to the validators or empty list or the array, right? However you call. So next, let's go with a this one helper method validate. So if you look at the this one UML diagram within the field, we have the validate method, right? So let me go with validate here. So one second, validate. So I'll just pass self here, right? So within the validate method, first thing, let's go with the list to store all the validation errors for this field. I'll just go with errors. May assign this one to the empty field, this one empty list. Next, let's iterate over each validator function assigned, right? Let's iterate over each validator function assigned. So I'll just go with for v in validator has to show, sorry, not this one. Yep, this one, validators. So within the for loop, we have to call the validator with a current field value. So I'll just go with result equals v of self dot. Let me go with the value. This one. Yep, so this is fine. Next, if the validator returns error message, then what we have to do? Then we have to append it, right? So let me write the simple if condition here. So this one has to start from here. If result actually, how can I write? Is not true, right? I'll just go with not true. Then what shall I do? I'll just go with, let's append the result to the errors, right? I'll just go with errors dot append of true. Yep, so this is fine. We have to append the result, man, not true. Yeah, we have to append the result to the error, sorry. This is fine. The next step, all we have to do is we have to return all the collected errors, right? So we have to return, sorry, have to return errors, right? So this is fine. We are done with this part. So this return has to be here. Sorry, yeah, not within the if condition. Next, let's move on with the next method actually, or yeah. So we have to define different validator functions as well. First, field is required and the field cannot be empty, right? So field is required and field cannot be empty. So I'll just go with here def required method, right? So let me pass the parameter value. We need the parameter value. So within this, let me go with a simple if condition. If value is none actually, if value is none or string, this one, let me pass the value. So this is fine. I'll just go with strip here. Yep, strip. Let me check whether it is equivalent to the empty string, right? So this is fine. If it is, then what we have to return, then field is required, right? So I'll just give here field is required. Yep, so this is fine. Next one is we have to return true. Then we have to return true, right? So this is fine. Yeah, so let me come out of this one entirely. Next, let's move on with the, so we went with required. Next, accordingly with the question, so we need the minimum length check as well. So I'll just go with def here, minimum length of, I need here n as parameter. So within this, I'll just go with def one more function named inner. So let me pass the value here. Yep. So within this function, let me write the simple if condition. If length of string, this one value, which is of the type string actually, if it is less than n, then what we need to do, then minimum length should be of n, right? So that is the reason we have considered the parameter n here. So I'll just go with return. So let me make use of the string interpolation here. Minimum length should be this is fine, n, right? So this is fine, and we will return true. Let me return true, else we will be returning inner, right? So else we will be returning inner. So let me return inner, right? So let me return inner, right? So this is fine. Next, what we'll be doing, we have to go with a maximum length check. So let me go with a maximum length check. I've done something somewhere wrong. I don't know what I've done wrong, but yeah, def validate is fine. Oh, this one I have to move completely inside actually. So this is fine, define them. So we are starting this one, so should be outside. We are just defining the different validator functions, right? So this will give us this one. What do we call? Mm, indentation error actually. So this one we have to move this one this side, both minimum length and required. Just give me a second here. So let me cut this one actually, and let me come here. Let me paste it over here. Also, let me cut this one as well. Let me paste it over. So now this has to be correct actually. This has to work correct. So next, let's do one thing. We are done with the required as well as the what do we call minimum length, right? So two rules actually. First rule, this one field is required and it cannot be empty. We went with this one required for that. And second rule, minimum length check. We went with a minimum length method. Next, maximum length. We have to go with a maximum length check as well. So I'll just go with a maximum length check. So let me copy the same thing and let me paste this one over here. So instead of min, I'll just go with the max length of n inner value. So this remains same actually. Instead of this one less than n, we are going with a maximum check. Let me go with maximum greater than n, sorry. And here instead of the minimum, let me convert this one to, or let me change this one to the maximum. Length should be this one. I have passed n and return true, else we have to return false, right? So sorry, return inner, right? So this is correct actually. Next, we are done with three rules actually. The fourth rule is email, this one email format validation, right? So for this one, I have opted to go with the this one. What do we call? Regex actually, regular expression, right? So I'll just go with here email validator. So let me, we need the value, right? So let me pass the parameter value. I'll just go with the pattern here and let me assign this one to, uh, let me paste this one, copy paste this one. Just give me a second here. So let me copy paste the regular expression here. So this is just the regex. You don't have to worry about it. So this is fine if just for the validation purpose, right? So if not, the dot, I'll just go with the match. Match has to show. Yep. So this is fine. Let me pass the pattern. Yep. Along with the pattern, let me pass this one str of value actually. Value has to show. Yep. So this is fine. Yeah. We're going correct. So let me return what we need to return here. I'll just go with invalid email format. Invalid email format. So this is fine, I believe. Yep. Next, let's return true. Let's return true. Right. So this is fine. Let's return true. Yep. So next, what we'll be doing, we'll be going with the age validator. That must be a positive integer actually, right? So I'll just go with def age validator. So this one, let me pass the value. I'll just go with the value age validator. So I'll just go with if not an if not, I'll just go with is instance. Yeah, let me go with is instance here. What shall I pass? Let me pass the value as well as int. This is fine. Or let me go with value less than or equal to 0. Then let's return age must be a positive integer. Age shouldn't go below this one 0, right? So that's what we are checking here. So let me return mm, age must be a positive integer. Yep, so this is fine. We are just going with a simple validation here, right? So return true, else we have to return true. So this is fine. We are done with this part as well. Next, we are done with the 5 rules actually, right? So now let's define the main form validator class. If you have observed the UML diagram, the main base class is form validator class, right? So let's go with the form validator class, which consists of the method add field and the validate, right? So this is the base class. So let me go with def, sorry, class, right? So I'll just go with class form validator. So, yep, this is fine. Within the form validator class, let me go with the initialization part here. Let me give init. So along with the self, I don't need anything. I'll just go with the fields actually and go with the fields. Let me set this one to the empty list and next only this much for the initialization part. We're just going with the fields basically which holds the list of all the field objects. Now we have to add a new field to the form. Right, I'll just go with def. Sorry, what is wrong here? Huh? What's wrong here, man? 1 second. Okay. Why this is not taking like this? I'll do one thing. I'll just go with def add a field actually. 1 second. Yep. So along with the self, I'll just go with the parameter field. We need the parameter field here. So within the add field method, so I'll just go with fields dot append. Fields dot append of, let me pass the field here, right? So let me pass the field. So this is fine. The next method would be, so we are done with adding a new field to the form. So we have successfully appended field to the field. So this is fine. This works. Next, we have to run the validations for all the fields, right? So let's go with the validate method. So I'll just go with validate here. Within the validate, go with self. So first, let me go with the dictionary to store the field name, nothing but list of errors, right? So I'll just go with errors, assign this one to the dictionary. So next, let me write the simple for loop for f in fields actually. Yep. So within the for loop, let me assign the results actually or result to this one validate. So let me go with validate. So we're just validating each field here. So next, what shall we do? I'll just go with if result. So let me go with error. Sorry, this one has to be errors actually. Yep. So I had misspelled actually. I'll just go with the f dot name. Let me assign this one to the result. Yep. So the final one here is we have to return the errors. We have to return the errors. Right. So I'll just go with return errors. So I'll just give here errors. Yep. So this is it for the code. Right. So this is completely based on the UML diagram. Right. We have successfully added the logic. Now let's go with the demo execution. Right. So as usual, demo execution or the example usage, I'll just take it from the Google. Just give me a second here. So 1 second, let me paste this one over here. So first what we are doing, we are just creating a creating an instance of the form validator, the base class, right? So the main class of the base class. Then we are adding several fields with their respective validators, username, I have given Manu here. Required minimum length, we have set this one to 3. Email, I have just given here Manu at YT. So I'm just calling this one required email validator, right? Age 0, required age validator. We are calling age validator here. The final one, password PW. So here max length, we have set this one to 12. All the things has to fail actually, right? So this is fine, I believe. Run validation. We are running the validation across all the fields by calling the validate method here, right? So finally, we are just displaying the results neatly. See here, if not this one result, then we have to this one. All validations passed, right? If we don't get any error, else we have to get the validation errors found along with it, the message actually. Yep. So this is fine. Let me do one thing. Let me format the code once. We have went with uh, we have written the code step by step actually. Again, I don't think we don't have to discuss this one again. Let me do one thing. Let me copy the file name entirely. I'll just give Control J here. Let me give clear screen. I'll just give Python followed by the file name.py. Me hit enter. Validation errors found. So this one, this passes actually. First one, the name passes actually. See here, Manu, minimum length we have set this one to 3, and this consists of the 4 letters. Quite obviously, it has to pass. The second one, we are going with Manu at YT. So email validator, see here, email invalid email format accordingly with this one pattern that we have considered, rejects that I have given, right? Age, we are going with greater than 0. It should be greater than 0, and we have given age here 0. If I give 1 to anything, it will work, but in this case we have given 0. So age, this also has to fail, and the messages that we have set when it fails, it is age must be a positive integer, right? So the final one, password, uh, actually we have set this one to the maximum length of yeah, minimum length 6 actually, maximum length 12, sorry. Minimum length, we have set this one to the 6, and maximum length, we have set this one to the 12. At least we should have 12, this one 6, this one characters, right? So here we have only 2, right? This should also fail. So this is minimum validation. Yeah. Uh, this is simple validation, sorry. Yeah, minimum length, we have set this one to 6, and we are getting only, we have given only 2 characters here. In this case, it has to fail with the error message that we have set. Minimum length should be 6. Yep, we are getting the desired output. Only thing that is passing is Manu. Actually, let me do one thing. Let me set this one to something like 31, right? So here I'll just give age 31. So let me give clear screen here. Let me run this one again. Yeah, so this is gone actually. So this works actually. This is correct. This is also correct. The only out this one, 2 things that are failing here. One is email, and another one is this one, password. Minimum length should be 6, right? So this is fine, I believe. Yep. So yeah, we have written the correct code. Whatever the code that we have written works absolutely correct, right? Accordingly with the demo usage or the example usage. Yep. So we are getting the desired output. So now, as we have completely written the code and we have discussed the coding part along with the output part, let's do one thing. Let's quickly discuss the limitations for the code that we have written. So let's go with the limitations of the code or limitations for the code that we have written, right? So first, no asynchronous validation for large data sets, right? So no asynchronous validation for large data sets. So this is one of the limitation. Next, it lacks the built-in dependency validation, right? So like confirm password, those kind of things, right? It lacks built-in dependency validation. This is also one of the limitation. The third one, no localization for error messages. Quite obviously, we haven't said, we went with a very simple code, right? So this is one of the limitation as well. The final one currently prints error to the console only, right? So we are going with a CLI demo. We are going with a single file CLI demo only, right? So concurrently prints error to console only, not structured to JSON. So this is one of the limitation as well. So these are some of the limitations for the current code that we have written. Next, let's move on with the alternative algorithms and the trade-offs, right? So first approach here, we can just go with a decorator based validation. Yeah, we can just go with a decorator based validation. So basically what it does, it defines the validators via decorators on fields, right? The trade-off for the summary here is uh, the syntax will be cleaner, but it is less dynamic, right? So this one we have to keep in mind. We can just go with a decorator based validation. The second one, we can go with a rule engine as well. We call this one as rule style. So what it does, it uses a rule based system for conditional validations. Yeah. So this you have to know. And the trade-off or the summary part here is it is more scalable, but heavier runtime. But heavier runtime. Yep. So let's move on with the third one here. So the main one, third one here is schema validation, right? Like JSON schema, like JSON schema. Yep. So what it states here, we will be defining the validation schemas declaratively, right? It defines or it this one schema validation, the JSON schema itself, it defines the validation schemas declaratively. Trade-off is it's easier for complex forms, no doubt, but it's less Pythonic. It's less Pythonic, right? So this is one of the things. The final one is parallel validation, right? So parallel validation in the sense we can just make use of the async IO, right? Async IO, what it does, it validates multiple fields concurrently. This is one of the pro actually, right? It is one of the advantages. Yeah. So it validates multiple fields concurrently. The main trade-off here is it is faster for the larger inputs, but it adds the async complexity. It adds asynchronous complexity. Yep. So this one we have to keep in mind. So these are some of the alternative algorithms that we can think of, right? So we have discussed alternative algorithms along with the trade-offs, right? So this is fine. Yep. Now what we have done, we have successfully designed this one, form validator utility, right? So we have successfully designed form validator utility, right? So we are done with this part. I hope whatever we have discussed is completely clear along with the coding part as well, right? Along with the coding part and the UML diagram. Yep, so this is fine. Next, mostly we will be designing the search indexer and the authentication system, these two things, right? So next, we'll be designing mainly search indexer, right? So for now, this is it. Thanks for watching, guys.